Hi everyone, I am Sri Devi, Professor of Department of Electronics and Communication Engineering, Dogini College of Engineering and Technology. In this video lecture, we are going to learn about minimum shift keying (MSK) in digital modulation scheme. On completion of this model, the learners can able to understand what is MSK (minimum shift keying). It is a special type of continuous phase frequency shift keying, which is peak frequency deviation is equal to 1 by 4 bit rate. In other words, MSK is continuous phase FSK with modulation index of 0.5. Modulation index means it is the average ratio between Vm by Vc. Vm is the message signal, Vc is the carrier signal. Modulation index of 0.5 corresponds to the minimum frequency spacing that allows two FSK signals to be coherently orthogonal, and name minimum shift keying implies a minimum frequency separation. MSK is a separately efficient modulation scheme, and it is particularly attractive for digital modulation techniques. An MSK signal can be can be thought as a special form of off QPSK, quadrature phase shift keying, where baseband rectangular pulses are replaced half sinusoidal pulses. So here in off QPSK the signal will be string offset. So of QPSK, the value of S is the power spectral density is calculated, and power is also calculated. When Mi of t and Q of t are the odd and even components, the data stream of plus or minus 1, it is calculated by RB by 2. RB is the bit rate by 2. One version of MSK uses the positive half sinusoids, and another version is uses the negative version of the sinusoid, where phi of k is 0, or it depends on whether m of m1 of t and it is plus 1 or minus 1. In MSK, minimum shift keying has the constant amplitude, phase continuously at the bit transition periods is ensured by choosing the carrier frequency to be the integral of the fourth bit rate 1 by 4t. MSK power spectrum is calculated as MSK baseband pulse shaping functions are given by the normalized power spectral density for MSK. So P of MSK equal to 16 by pi cube cos 2 pi f plus fc divided by t divided by 1.16 f square t square the whole power 2 plus 16 by pi cube cos 2 pi f minus fc by t divided by 1.6 f square t square the whole power 2. The MSK spectrum has low side lobes than the QPSK and off QPSK. So 99% of MSK power is contained within the bandwidth B equal to 1.2 T, while QPSK and OQPSK the 99% of bandwidth B is equal to 8 by T. So here this is the spectrum. Here the spectrum x-axis frequency and y-axis the power spectral density in dB. So it is like this. MSK is like this, and dotted portions represents the QPSK and OQPSK. The faster roll of MSK spectrum is due to the fact that smoother pulse functions are used. Here this shows the main lobe of the MSK is wider than that of QPSK and OQPSK, and hence it is compared with first null bandwidth. The MSK is less separately efficient with the phase shift. So here the MSK this is very much useful in this minimum shift keying. So here it is all this digital modulation techniques are used in mobile switching system.